So the topic for today is going to be Spring Boot with Netty. So basically, you guys have used Tomcat and you guys have used Spring Web module and you guys have worked with Spring Web MVC. Basically, whenever you are developing your REST API or you are creating some web application, you have pretty much used the Spring Web module. So right now, we're going to be diving into the Spring WebFlux module. And as you guys know, like in the Spring WebFlux, we are using a server called Netty. We have done pretty much of hands-on with Spring WebFlux. So if you guys are completely new to Spring WebFlux and joined this session, then also fine. You can get a lot out of it. So I will not be talking pretty much how the WebFlux works today. I will talk about whenever a client or a browser is going to send a request, and whenever you are using a Netty server using with your Spring Boot, then how your Spring Boot handles that request and how Spring Boot processes the user request. Okay, so Spring Boot with Netty is going to be the topic name, and we're going to be seeing under the hood how the Netty server works and how the Netty server processes the request. And it's usually a different kind of model if you're going to compare that with the Tomcat with Spring Boot. So now, as I said, the Tomcat and the Netty, they both are having some different model. And as I have told you, if your server wants to handle millions of requests, you want a better throughput, you want to effectively utilize your resources, and you want to build non-blocking API, then go for the Spring WebFlux module, right? And you're going to be using the Netty server. But now the question is, like the Tomcat works with a thread per request model. Each request is going to be handled by one particular thread, and that particular thread is entirely responsible to process that user request. The problem here, as I have already told you, in the thread per request model, one thread is going to handle one user request, and if the user request is basically demands some huge amount of data, then that thread which is handling that user request is going to be blocked until and unless your response is being served to that particular user. Now, the Netty here that we're going to be using with Spring WebFlux, that basically uses a event loop model. Now, ladies and gentlemen, here is the hero of our story today, event loop. And that is something that we're going to be talking about right now. So the Tomcat works with the thread per request model, and the Netty works with the event loop model. Now, what is the event loop and how the event loop works and how the event loop is going to help you to handle tons of requests. When I say event loop, this is how an event loop looks like. Okay, so what is this event loop? This is actually a thread. Okay, this is actually a server thread or worker thread, which is going to help you to process the user request. But using this one thread, you can serve so many requests. This thread can serve my request, your friend's request, and so many concurrent requests at a time. Okay, which is completely opposite of the Tomcat's thread per request model, right? In the Tomcat thread per request model, one request belongs to one thread. And that thread is going to serve that request, and only after it complete processing that request, it is going to pick off a new request. But this one doesn't matter. It is going to serve my request, okay? And if I'm going to ask a lot of data, let's say, okay, this is my request, and I want, this is a huge number of data that I want, so make a DB call and get me the data. Now, this event loop will see, oh, okay, so this is a IO intensive operation. So what I'm going to do, I'm going to offload this request. So this data finding thing can go in the background. And in the meantime, I will not sit idle. Okay, I will not be get blocked. Okay, and I'm going to go and serve anyone else's request. Okay, this is how the event loop model works if I'm going to put the story in short. Okay, but how exactly the things works, let's just have a look over here. Okay, so this is the event loop. So as of now, whatever the discussion that we had, event loop is just a thread. Okay, this is what we call the worker thread with or your server thread. This thread is basically there inside your server. Okay, which server? Netty server. Right now, I'm not going to be talk about the Tomcat thing. Okay, now imagine this is a computer, this is a client or a browser, which basically sends a request. Now, when this request comes, the request is going to hit the server, right? So server in the sense, you can think like the Netty server, which is your Spring Boot application, okay? Now, once this request hits the Spring Boot application, how this request is going to be processed and how this request is going to reach over here inside the event loop so that the event loop can process that request. Because to process a request, you need a thread, right? It is that thread. If you want to do something, you need a thread, whatever programming language that you are using, doesn't matter. So this is a request, this is a task that I want to do, I want to perform. So I got this event loop. Using what I can process this task. Now the thing is, to process this request, first of all, we need a kind of connection. This is a client, and imagine this thing is there inside my server. So my server and the client need to do a handshake, okay? And handshake in the sense we need to open a TCP socket or a connection in simple word. So the way we represent connections over here in the Netty server, there's something what we call a channel, okay? So this is a channel kind of thing you can think. The channel means it's a connection between the client and the server, and this is the channel. Using this channel only, this request will be processed and will be sent to the event loop so that the event loop can process this request, okay? So any conversation will be done between this client and the server that will go through the channel. So you can think like the channel for the communication where your request and response will flow and these two guys will talk to each other, okay? So overally it's a TCP connection, but in Netty, under the hood, it creates a channel, okay? You can think like that. Okay, now the thing is that this channel that we have created for this client using what it is going to do the communication, to process this request to here, we need to make sure our channel is registered with the event loop, okay? So this is the registration, okay? So once the channel gets created, Netty is going to make sure it is going to create a bridge between this event loop and this channel, okay? So that our request can flow using this channel, okay? And this is the registration. Our channel is being registered with the event loop right over here. And once this is done, I can think like this request is getting converted to a task, or I should better phrase it as an event. Event means what? It's just something which is happening, right? This request which is coming, we're going to be converting that request to a task or an event, okay? And the event loop is going to process this task. You can think like that, okay? So this is a task or event. Now to process this task, we need to put this task over here inside this thread so that the event loop can process that task. Now the task will not directly go to here. Each event loop that we have or this thread, you can think like this is a single thread or what we are calling event loop. This guy does have a queue, something like this. This is the head, this is the tail. And the event loop is going to pick the task from this queue only, okay? Now this is the task which basically we have created from this request. Now this task which is coming through this channel right now going to be post inside this queue. So we're going to put this task over here, okay? Now this is our event loop task queue. Every event loop does have their own task queue, okay? And there goes our event over here, or there goes our task. Now the event loop is going to pick this task and going to process this task, can give it CPU time to this task for the execution. And once the execution is done, this is again going to be sent to the channel, and the channel is going to send the response back right over here to the client, okay? This is how your event loop works. All right, now I know it's all theory right now. Don't worry, I'm oversimplifying this thing. Okay, I don't want to bring in all the Netty internal components right now. Just understand it. It's a very simple thing, right? So I'm going to show you one more slide. We're going to go technical a little bit later, but just understand overall how that works. And just understand it one time, then it will be easy for you forever, right? So this is the core concept of how the event loop works. Once you understand the core concept, you can go ahead and can explore by your own as well. Okay, now let's just go to our next slide. Okay, now look at this. We have the event loop. The event loop has its own task queue. So whenever the request coming from the client, the task is right over here. The task is getting created from the request, and this is in the channel. Through the channel, the request and response flow will happen right over here. Now this is the request. The channel is going to post this request right over here inside in the event loop, but the task will come to the event loop task queue first, and then the event loop is going to pick the task from the event loop task queue. Let's just see how that happens. Now what you are seeing over here, we have couple of client. Imagine these are couple of browsers. Imagine this is my browser, this is Avisec's browser. We are two different client. Okay, now whenever I'm gonna send some request, okay, the connection between my system and the server will be open. That will be open through a channel, and all the requests, all the HTTP requests that I'm sending, okay, that will go through the same channel that we are creating. And once our conversation over, the channel will disappear. So you can treat the channel like a table, okay, table in a restaurant, right? So imagine this is you, this is your table in the restaurant, and this is the waiter, okay, this is the waiter which is serving the request from each table. Like this is the request that you are giving to this waiter. This is the request that you are giving to this waiter. So the waiter is going to serve the request by taking it from each table. So this is the table, this is the table, and this is the task or the order that you are giving. You can think like that. Okay. So each client will have their own table. So whenever you are going to a restaurant, you sit in a table, right? So that is your table. So each client does have their own channel, okay? And that channel is registered with the event loop. You can think like this is your waiter in your restaurant, okay? So now let's say, this task, this is the order that you're giving. So this task goes to the queue. Okay, let's say this guy came first and say, okay, here is my task. So it goes to the queue, and this guy again, there is another task, that goes into the event loop task queue, something like that. Now this guy will take each task from the queue, and this works in a FIFO model, first in, first out. Okay. Now this task came first, will be picked up by the event loop, will be processed, and then let's say the food is ready. Okay. Now it is going to give you back the result, and now that will be processed through this channel. Okay, so next one, it will be picking this task from the queue, and it will be processing it. It will be giving back the response, and now there goes the response over here. Okay, this is how the event loop works. And if you want to simplify this, if you want to see this, you can think like there are so many tasks will come and will be placed inside the task queue, something like this. And the event loop is going to process each task, something like this. It's going to pick each task over here, or you can think like these are the requests. It's going to pick each request. 1 second, don't put anything on the chart for now. Okay, it's going to pick each task from the queue and going to process this like this. Okay, so this is the event loop is a thread which is going to help you to process all your user requests, and the task over here means a user request that we are serving. Now I can see your chart.
So, sorry, Abhilash.
Okay, no problem.
I forgot why it is called event loop.
Because it is processing the event. So basically, they said this
loop means
loop
closed,
means
right?
Okay. I'll tell you why it is called an event loop. See, this loop, a loop means what? You tell me what is a loop?
Something like closed, round.
Yeah, something like
repeating.
Yeah, repeating the things, right? Now the event loop is a thread, okay, which is going to keep serving the request in a loop. The event loop always going to check whether there is something inside the task queue. It is going to keep picking the elements, something like this. Let's say there are a lot of elements like this. These are all requests, okay? These are all events. The request which has been converted to event, and these are all callback events. I'll come to this later. All these events will be picked up by this loop, and the event loop is a thread which is going to serve this request or task. Then again, it's going to pick it. One second, guys. Now it is going to pick another request. It is going to pick another request and going to serve this. And it's going to pick another request and it's going to serve this. So it goes in a loop. And whenever there is nothing there inside this task queue, it is going to wait and idle. But as soon as something arrives over here, it is going to keep picking and keep serving. So this is one thread which goes in a loop and serving all the events or all the tasks that you have over here inside the loop. Got it?
So, yeah, got it. But if some millions of requests are coming, this queue keeps on getting increased, right?
Exactly. That's a good point. Now the thing is, Sunil, I'm coming into a point. 1 second. Yeah, Mahesh. So basically, you are correct. One event loop can process so many requests. How many? So many. Can I process 100 requests using one thread? Yes. Yes. But the thing is, if you have millions of requests, as you are saying, can you have more event loop? Exactly. We can have more event loop. And here in your Spring Boot, whenever you're going to start Netty server, you're going to be seeing a lot of event loop. And whenever I'm saying a lot of event loop, that means it is a thread only. So a lot of threads you're going to be seeing whenever you're going to bootstrap your Spring Boot server. And in Netty server, if you are starting your Spring Boot server with Netty, you're going to say those things as event loop only. Okay. So you remember, like in Tomcat, basically whenever you start a Tomcat server, there are lots of threads you are finding. Whenever you are starting the Tomcat server, by default 10 threads are there, which are your worker threads. Something like that, whenever you start your Netty server, you're going to be finding 10 or 14 based upon your CPU core, how many CPU core that you have. Let's say I'm having 14 CPU core or 20 CPU core. That means there will be 20 event loop which will be automatically created by your Spring Boot server. And each event loop will have their own task queue, and each event loop can serve request. Okay, imagine this is one event loop. We can have another one like this. This is one thread, this is one thread. Imagine with this there are few clients. 2 requests are getting served by this event loop. Okay, now this is a channel which has been opened, and the connection has been established. So now imagine this is my machine, this is your machine, Mahesh. We both are registered with this event loop. This thread is serving 2 of our requests, or maybe Sunil joined, or maybe Abhishek joined, and all of our 4 requests is getting served by this event loop. So all of our 4 people, whenever we are communicating, our task or our request will ended up inside this queue, which is basically meant for this event loop. So every event loop does have their own task queue. Like that, this is another event loop. And for this, there may be, let's say 2 more machine has been connected. Okay, imagine this is someone else machine, your friend's machine, and this is a channel. Okay, using what the communication will happen. And this is another machine, and this is the channel using what your friend will communicate. Imagine this is 2 of our other friends, and their request will be served by this event loop. So whenever they will be sending requests, their request will be converted into events and will ended off in this loop. So this event loop will pick up the request from this and gonna process that. Make sense? Whatever I said, that much only.
Yeah, Abhilash. So as you said, like, so these requests will be served one by one, not parallelly.
Exactly. Yeah. 1 second. That's a very nice point. See, whenever the request sent, let's say this request has been sent, this request has been sent, all this request will be posted over here. Okay. Let's say sequentially, in a first in, first out manner, the event loop is going to pick up the request and going to serve it. You may think, okay, Abhilash, what about the first request that I have sent? What if, it is, let's say, imagine this one. This is a very nice point, Mahesh. Let's say there are so many requests are placed over here. Imagine all these requests came from 3 different client. And this is, let's say, Abhishek's request. This is my request. This is Amrita's request. There are 3 requests. Now this event loop first pick my request. Okay, process this. That's fine. Then let's say it picks Mahesh's request or someone else's request. Imagine this request is very much IO intensive. That means he's asking a lot of things. Okay, get me millions of record that I have in the database. That means this request is going to take so much of time, right? So if this request is taking so much of time, if the event loop is going to wait to process the request, then there is a problem, right? But doesn't matter. Whenever this request event loop say, okay, this is taking time, this is just going to offload this request, okay, and gonna put it somewhere else. Okay, you go ahead in the background, you do the task. In the meantime, I'll give my CPU time to one more request, and I'm gonna be processing that request. And now, when that the other request is ready, this is going to do a callback. All the tasks that we are creating over here, those are all callback thing. Once the response is ready, then that event loop again going to pick that request and going to process it. How that actually happens, let me show you in this slide. And this is the important slide, one last slide before we're going to jump into the code, and I'm going to be showing you everything that we are discussing over here. Okay, so how that IO intensive tasks are getting performed. So the next slide, important one. If you understand this, then you can understand the code in one shot. Okay, this is the beauty of your Netty server. This is why the event loop is a hero. It's just amazing. It's awesome because of this reason. This is how exactly it works. Okay, now see, there is a task here. Okay, imagine there are a couple of clients, all are registered with this event loop. So the request and response, everything will go through this channel. Okay, this client has its own channel, this client has its own channel, all looking good. Now imagine this guy sends a request. This is the task. The task goes to the event loop task queue. Okay, the same client sends another request. The task goes to the event loop task queue. Fine. Now there is another client making another request, okay, and the task goes to here inside the task queue. Okay, now imagine the event loop picks the first task and gonna process this task. Now the event loop finds that this is a IO extensive call, or it's a blocking call. Okay, it just needs so much of background thing to be done. Imagine it's making a DB call, and the database call need to be made and the data need to be fetched, so it's going to take some time. So the event loop see, okay, this is a IO intensive task, so I need to offload this task to somewhere else. This is not completed yet, but I'm going to offload that. And this place, so this is my blocking IO. All the blocking IO call, the tasks which are making any blocking IO call will be uploaded to this area. Okay, now event loop does have this area, and it is going to move the task or offload the task to this area. Okay, now the blocking IO is going to do what? It is going to execute this task, right? Now to execute this task, we have a separate thread pool. Okay, these are not your event loop. These threads are different. Imagine it's our executor service or a different thread pool that we have created where we have a bunch of threads. Now this blocking IO call that we made over here, this task, internally is going to pick one of this thread from the thread pool and gonna make a call to the DB. Okay, and imagine this is a blocking call, so it's gonna take some time. So all these things is happening behind the scene in the background, right? Now the event loop in the meantime, this is not going to wait. By the way, this is going to pick another task, okay, and gonna process this task. Imagine this is just a normal task, doesn't just need a little bit of CPU time, not doing any IO intensive task. So this will be served back to the same channel, whoever sent this request. Event loop basically knows who sent this request, so it sends the response back. It picks up the next task, then it's also not a IO intensive task, goes to the same client, whoever actually asks for the request, the response has been given. And imagine in the same time another request came from a different client, so that basically ended off in the event loop. But in the same time right now, what happened, this blocking operation which is happening behind the scene, now this task is completed. Okay, now this is done with the task, and this task is ready, and now the response is ready to be served. Now what will happen, as I said, this task, whatever we're creating, these are all callbacks. These are all runnable tasks. So whenever this task completes, So this task makes a callback to the event loop that, hey, I'm done with my task. But the event loop says, okay, don't worry, I will serve you, but I already have something before you. So this task will be pushed to the same event loop task queue, and now it is just over here. Okay, this is not going to get the priority. It is going to get the priority if we have nothing in the queue. So now we have already a task which is from this channel. So the event loop first will pick that task. Okay, we'll process this. I'm going to give back to the channel, and the response is served. Now it is going to pick this task. This was our first request, if you remember. Now it is done. The event loop knows that, okay, who sends this request? The event loop kind of tracks that, and now the event loop sends the task whoever basically hears this request and goes to the same channel. As I said, this is the channel where this client is communicating. If this is me, this task will be sent to me, right? So this is how the event loop basically can serve so many requests at a time. And this event loop is actually non-blocking because it doesn't block. It just keep picking the task, keep executing. If it triggers, there is something which is going to take time, it is going to offload it. And then once that is completed, the task will be again sent back to the queue, and the event loop is going to further process it and gonna send to the channel of wherever it basically receives the request. You might think, okay, Vilas, how the event loop will remember who sends the request? Because we're offloading it, because in the thread per request model in the Tomcat, whichever thread basically handles the request, that thread only going to serve you the response, and then only the thread will be free, and then only the thread is going to pick off another request. But in the event loop, it doesn't happen like that. I'm going to send a request. This event loop thread is going to pick that request, then see, okay, this is a IO blocking call. It offloads it, okay? And it's going to pick off someone else's request. I'm going to process it. And whenever my request is ready, event loop is again going to pick that off from the queue and going to process that. Now, how does it remember? Yeah, this, again, the WebFlux is all about the callbacks, multiple things involved. So the code becomes a little complex, and the WebFlux is making it easy using all the Spring Boot stuff. But the internal code, if you're going to do it raw, then this is going to be a little bit complex, and this adds some kind of complexity. That's why learning Spring Web using the Tomcat is easy, and WebFlux needs a different learning curve. That's why I always say. But this is how the thing works internally. As easy as that. This needs a little bit of learning curve, so don't get discouraged. This is very, very easy. Just like you have started learning Spring Web, like that you have to learn Spring WebFlux using Netty. This tech stack is booming. I'm using it. I think so many of us who are in the meeting, you guys are using it, and people are looking for developers who know Spring WebFlux. So don't ignore this module, and this is how the Netty server works behind the scene. Okay, so we're going to be proving all these things, and I'm going to show you everything in log quickly with a Spring Boot project. So that is a matter of 10-20 minutes. We can go to that right now. But overall, the concept is clear, like how the event loop basically works. Guys?
I have one question.
Yes, Mahesh.
You know the event loop queue size? Is there any size?
Let's not go into the internal thing, Mahesh. Okay. And one more thing also I'll tell you. I also haven't told you over here a lot of internal things. I just try to make it so simple, okay? But internally, Netty has a lot of different components. I just told you about channel. I just told you that whenever the request came, the channel is getting created. Once the request response is over, the channel is going to be disappear and will be cancelled and will be terminated, right? So like that, there are so many internal components are there. I'm not mentioning those things, okay? Just to make things easy, we don't give a damn. Do you know every internal component of Tomcat? You don't need to know until and unless you are working extensively with Tomcat as an admin or something, right? So I'm trying to make it very simple, but in our WebFlux session, later in the advanced section, we may talk about all these things and going to touch the internal components. So let's just go to the coding thing right now. Any other questions we have for now?
Yeah, Avinash.
Yes,
so
opening.
When we start the application, then that time multiple event loop will be created, or
exactly. We will see that, Sovnik, right now. And the answer is multiple event loop will be created. In your Spring Boot application, Sovnik, let's say I'm using this MacBook and I have 48 GB of RAM, processor. Okay, I don't have the processor information over here, but you know how to find the available processor, right? I think system.getRuntime.get available processor.
Get available processor, yes.
So it's basically how many cores that you have multiplied by 2. That many event loop you can have in your machine. How many event loop you're going to have in your machine, how many event loop that I'm going to have in my machine, that is going to vary. Okay. So in let's say my machine has 10 cores, but you have a powerful machine which have 20 core or 30 core, for an example, I'm telling you. Then you're going to have that many number of event loop available. Okay. So how many event loop will be available in your machine depends on how many number of cores that you have in your machine. Okay. So in your Spring Boot server, whenever I'm going to be starting my Spring Boot server, I'm going to have multiple number of event loop which will be available. And those what we call the event loop group. This is a very nice question, by the way. I will tell you, Sovnik. So in your Tomcat, you have a thread pool, right? So where you will have multiple number of threads.
Yes.
Correct. Like same as this also. So I'm gonna show you a little bit. Nice question. Imagine in your Tomcat, you'll have threads like this, right? Each request which is going to come, that will be basically assigned to a thread.
Correct.
Let's say there is another request coming, another thread will be given, another request will coming, another thread will be given. And this thread, what we call worker thread in Tomcat. Same in Netty also. Okay. Whenever you're going to start your Spring Boot application, you will also have a number of threads. Same. You can think like this is your number of threads you're going to have. But now these are not normal threads. This is also worker threads. We're going to call them as worker threads only. But each of these worker threads, what we call event loop. And that is basically depends on how many number of cores that you have in your machine. That many threads you're going to be having, or multiplied by 2. That many threads you'll be having available right over here. But as I said, each event loop is very powerful. Each event loop can serve hundreds and thousands of requests. Now we can give all these requests to one event loop, something like this. Okay, this is the beauty of this event loop. And this is the same question Moez asked. To do this also, we can assign 10 requests, 20 requests, 30 requests, 100 requests, 1000 requests. Okay, that's also fine. This event loop can process all these things because it will never be blocking. It will never go blocking, right? Whenever there is something blocking happens, it's going to offload that request. Makes sense, Sovnik?
Yes.
And also one more good thing you can remember. Okay, I don't want to go into the internal. That's why I avoided Moez's question. Don't want to go into this as well. Just for your understanding, this is what we call number of threads are available over here inside the server. So how do we refer number of threads together? What is that term?
Thread group.
Thread pool. Correct.
Thread pool. Correct.
Thread pool, no? Where we have number of threads. And here also, these are number of threads, what we are calling event loop. Okay. And number of event loop together in Netty's language is called event loop group. Okay. Event loop group means thread pool only. You can think like. Okay. Here in Netty, I'm going to say this is the event loop group, which has 4 number of event loop. Which are like all worker thread which can serve request. Now you can think like this will have channels like this. This will have channels like this. Channel means all this request whenever will be assigned to this thread, they will come through a channel, as I said, right? The connection you need to open between your server where the request will be processed, right? So each event loop will have their own channels. Together they will be referred as event loop group. And actually guys, there are 2 terms. I don't want it to go into this term thing, but one second. If we are discussing, let's just talk about this. The first thing is I told you event loop. Then another thing I told you event loop group. Okay. These 2 terms are, I hope it is clear. And there is another thing, this event loop groups, right? There are two types of event loop groups. The first type in Netty, what we call boss group, and another type what we call worker group. Okay, boss event loop group and the worker group. So what basically this worker group does, you already know. These threads are already what we say worker threads. This worker threads is going to help you to serve a request. Okay, somebody comes, hit your server, you need one of this event loop. From this event loop group, this is the event loop group, from that you need at least one event loop to process that request, right? So this is what we call worker group, and these event loops are called worker thread. That's why we are saying worker thread group or worker group, whatever. What is this boss group? The boss group means this is also one of the event loop. Okay, boss group means there are some event loop goes over here. Worker group means there are some event loop goes over here. The worker group are responsible to serve the user request. The boss group, usually it is one or two event loop, and this thread is responsible to accept the incoming request. Okay, so in Netty there are two types of event loop which are available. The first type is worker threads, which are responsible to serve request, and the boss group is basically which comes first and handles the incoming request, creates a channel, and then sends it to the server. Then the worker group basically continues their works over there. Now this channel creation thing, this thing is basically taken care by another event loop when it comes to Netty server, right? But don't want to complicate this. Just remember there are two type of event loop group that we have inside your server. All these threads, one thread or two threads are boss, and rest of the things are worker. Worker serves the request. Boss basically manages opening of the channel and setting up the connection between the client server, the handshake thing, and all that. Okay, I think I'm not confusing. Can you confirm me once?
Yes, Abhilash, it's clear now.
Now I just want to get some feedback.
Yeah,
Guys,
Abhilash, is it good for more blocking IO application?
It is good for blocking IO. Yes, this Netty is good for blocking IO only. I'm going to show you an example right now. Because
if there are more blocking operations, all the tasks will be offloaded.
Exactly.
And queue will be, whenever there is callback.
That's why you're asking the size of the queue. And I said,
yeah,
I do understand. But the thing is, you don't have to worry about it because you have so many event loop threads available. They will have their own queue. Okay, that configuration part is a different thing, and they will have their own queue. And let's say this event loop will have its own queue. This event loop will have its own queue. This event loop will have its own queue. So you are thinking whenever it will be uploaded, it will be processed by some other threads, not by these threads. Okay, these threads are event loop which is going to handle the request. And whenever it is going to offload it, there will be some block in a bunch of threads, which will be some executor threads or something that will be helping you to process those requests. Once the task is done, it will be again come back to the queue. Don't worry about the size and all that. We'll talk about all these things, Mahesh, maybe in our advanced WebFlux session. But the thing is here, it is as simple as that. There is a queue which is getting maintained. All the complexity things taken care by your Netty things. You as a developer don't have to worry about all this thing.
Okay? Yeah, listening all this, like I'm getting so many things in mind, like why I'm getting feeling like virtual threads concept, like
I understand. So I understand because you already know that concept, right?
Yeah.
But this is more powerful. For me, the WebFlux is more powerful. Virtual thread is good. It's good. We already have seen a lot of things about the virtual threads. It's good. But this thing is even better. Virtual thread is a new thing. But this thing is proven, used by many people. Even you are only using it, Moez. You said already to me, I think. We're already using this, right? So, so you guys know this stack is already popular. But am I making sense with all this thing? Guys?
Yes, Abhilash.
Now I want to hear it from everyone. Just tell me, did I confuse you?
Clear, Abhilash.
Not too much.
Clear, Abhilash.
if we have n number of tasks, can we invoke all threads at one shot? If we have n number, yeah, all the event loop can process, all those event loop can process parallelly. In the task queue, this is sequential. For event loop, if it is going to pick something from the task, that is sequential. One by one, it is going to be keep on picking. Okay, let's just go to the IntelliJ and start coding. So we'll complete this quickly. We are running out of time. We have 10-15 minutes. Within that only you will complete. Okay. Okay, so let's just create a new project right now. I'm gonna call this producer application, and group ID will become .selenium_express.producer. Okay, there we go. Version Java 21 JDK. Do I have 21 JDK? Okay, let's go with 24. Next, I will need the Spring Web. Okay, just create the project. Okay, this is going to be a producer application, guys. So what I'm going to do, I'm going to create a simple endpoint. So we're going to create a new class, and I'm going to just create a class called producer controller. This is going to be a simple controller which is going to produce some data. Okay, first of all, I'm going to make it a REST controller, and I'm going to maximize this. Okay, and over here, I'm just going to have a public string. Let's say get data, and I'm going to just get some data. Let's say I'm going to say return, whatever. Let's say hello world. Okay, and this is going to be having an endpoint, and let's say the endpoint is hello. Okay, simple REST controller that we have. And let's just do one thing. This application, let's just start it in a port number, server.port. Let's just configure to 8081. Okay, simple. And let's just start this application. So I'll go here and I'll start this. Okay, now this is running in Tomcat, so that's fine. Let's just check our endpoint, 8081/hello, and there you go. We get hello world over here. Now we have this endpoint, which is a producer endpoint, which is going to producing some data called hello world. I just want to do one thing. I just want to create some kind of a lag over here. So I'm going to go with a thread.sleep here, thread.sleep, and I'm going to wait for 10,000 millisecond right over here. And this is going to throw some exception. I'm going to add it to the method, and I'm going to restart this. Okay, so I'll go to my application and I'll start my application, and this data will be produced, but it will be produced after 10,000 millisecond, which will be after 10 seconds. Okay, so just wanted an endpoint which is going to produce some data. You can see it's rolling, and after 10 seconds only it is going to produce me the data. Simple endpoint that I have created. I think you guys got no question with this, right? Now we got the data. Can you confirm me? Then I can go for the next thing.
Yes, clear with us.
Okay, nothing is there, so nothing to ask. So that's fine. We have our producer application which is producing some data, but with a little bit of delay. Now, whenever we're gonna call this endpoint, you can see that delay. So whenever somebody is going to hit this endpoint, it is going to make themselves wait for 10 seconds. So you can think this is a blocking operation, and whenever somebody is going to hit this endpoint, their request is going to be blocked for 10 seconds. So what we do not want, if it is normal Tomcat, this is a Tomcat, application, right? So, and you also know whenever we are starting our Tomcat application, by default, the Tomcat will have some thread pool and some worker thread behind the scene. If you're going to go to the threads and variables, these are all the Tomcat worker threads. And one of the thread from here is basically serving the request, right? But the thing is that whenever I'm making a request, let's say this thread picks up that request, then this thread will be blocked for 10 seconds. And for that 10 seconds, this thread will not do anything. which is not a good thing, right? We do not want our thread to be blocked because we cannot create so many threads. So whatever the number of threads that we have in Tomcat, we can go up to 200 threads. So within that 200 threads, we have to manage all the incoming requests. And the Tomcat are by default blocking. That means these threads are blocking. Once it handles the request, it will be blocked. Okay, until and unless that request has not been served to the client, that thread will be blocked and will not be able to pick up any other request. And that is something that we are trying to solve over here. Okay, but you understand all these things, so that's fine. So this is our normal Spring Boot application which is running on Tomcat. Now let's just do one thing. Let's just try to do whatever we're supposed to do right now, and let's just create a consumer application. Let's create this in Maven, and I'm gonna say com.selenium express consumer, and this is the consumer app, and this is going to be my package name, and I'll go for the JDK 24, 17, Maven is selected, Java is selected, all good, next. And here I want to create this application using Spring Web, but not the normal web, not your normal web MVC. I want to create using the reactive web. And I'm going to do a create. And I'm going to say new window. So I got it over here. So 1 second. I think you can see this. This is my producer app, which is up and running in Tomcat in 8081 port number. And this is my consumer app. Okay. And this is my consumer app that I have to code over here. My producer app is up and running. So what we are doing, that we have this endpoint, we need to consume this endpoint, and we're going to be seeing the behavior with whatever we understood, right? And this is a blocking operation, and that's why I have created this endpoint. Now let's just go to our consumer app, and let's just go to source, main, Java, and right over here, let's just create a new Java class, okay? And this is going to be our consumer controller, okay? Create this. And this is going to be a REST controller, okay? And the next thing that we're going to be doing over here, we're going to create a method called public mono of string. Let's just do mono of string, and let's say mono. Why I'm doing, because we're going to be giving a response, one response. So that's why I'm writing mono. One thing only we're going to be sending, and I'm going to say consume data. Okay, that's it. And we're going to be returning some data. So I'm going to say mono the just, and let's say here is my data. For now, I'm going to hard code it. I'm not making any call. So I'm going to say here is my data. Okay, there you go. And I just need to give a get endpoint. Let's say get mapping. And I'm going to say /consume. Okay, let's say I'm not consuming anything, by the way. Here I need to make my REST call, and I need to make the REST call to my producer controller. Right over here, I can make a call to this hello endpoint, and this is going to get me the hello world, and that's what I want to consume and I want to print over here. This is my goal, but right now I'm not doing those things. I'm just hard coding these things right over here. But later I'm going to be making the REST call here. Okay, so things are good. So let's just see whether this thing is working or not. So I'm going to go to my consumer app right now. Let's just start my consumer app. So as I'm using Spring WebFlux, now whenever I'm going to start in debug mode. So whenever I'm starting, it is going to start in Netty, right? So you can see the Netty server has been started in port number 8080. This is not your normal Tomcat server. Now the first thing that I want to show you over here, in the threads and variables section, in the threads, if you're not getting this threads option, you need to enable it somewhere from here. You have to tick threads over here, then only you'll get this option. So if you're going to go to the thread, you can see there is something called reactor-http-nio-1. Okay, why this is Neo? Because behind the scene, this is Netty framework, and Netty works on top of the Java Neo framework, and Neo means non-blocking IO. Okay, so a reactor-http-nio-1. This is your event loop, guys. Okay, this thing is that you are learning throughout. Okay, this guy. This is your event loop. Okay, Now, if you're going to go to your IntelliJ, this guy is your event loop. Okay, this guy is going to help you to process all the incoming requests. Okay, now if you're gonna do one thing, if you're gonna go to your server, now let's just hit our endpoint, Control C, Control V, and this is on 8080 port number. There is an endpoint that I have created called consume. Okay, enter. It is just saying here is my data. Now, whenever I send this request, all those things that I have told you is happening behind the scene. Okay, and this HTTP Neo1 is basically, or maybe there are so many, now you can see your server created few more event loop. Okay, now someone of you was asking me, okay, how many event loop will be created? Depends on how many cores that I have. And how many cores I have, if you want to check anytime, you can just log it, s out, let's say number of cores, and I think how can I print how many cores I have? Available processor, right? So let's just restart this. Now this is going to help me to print how many cores that I have, this line. Okay, so if I'm gonna go over here, gonna hit this endpoint, I got the respective thing. I can check my console, see number of cores that I have is 14 right now in my machine. So eventually there will be 14. So now you have 3, but you can see once you start making more and more blocking operation, you might get 14 number of event loop running together. And this one can serve many requests, this one can serve many requests, this one can serve many requests. And these are your event loop. As of now, are you guys clear? Event loop means what? This is a event loop. You understand?
Yes, it's Abhilash.
No,
Yes.
am I confusing? Tell me honestly, am I confusing?
No, it's clear up to this, Vilash.
Yeah, Abhilash, it's clear.
Okay.
Yeah.
Venu, you're good? Firaj, if you have any question?
Yes, it's clear.
Okay.
I'm good, Abhishek.
Okay. Is it so much for now? Are you getting burdened? Your mind is working, right? You're able to capture all these things, right? Or do you want me to wrap up right now? I know I have taken a little bit of time. Can I complete this? 10
Yes,
10
yes.
minutes more.
Yes.
Vilash, one question.
Ask me your question. Yes.
This event loop is working as non-blocking, but eventually that non-blocking request which we are parking, that is also using a thread, right?
Exactly. Those are not this thread. I'll show you. And that's a good question. See, let's say this is some data. Okay. If you don't understand WebFlux, just remember this. This is a reactive way of doing the same thing that you are doing in Spring MVC. Okay. Here we are sending the data. This is our data we are returning, and this is the data you are getting whenever you are hitting this endpoint. Just remember that much if you're just watching it for the first time, because I can see there are few people where for you the Spring WebFlux might be new. Now what is all this mono and why I'm writing all this? For that, follow my WebFlux session. Okay. Now the thing is that I want to create a delay. Okay. So I'm going to set delay element, and I'm going to say duration and duration.op second, and I want to delay for 5 seconds. Okay. Or 10 seconds. Okay. Here only I'm just creating an intentional delay. Okay. Let's just restart. Okay, and obviously this is going to be delay for 10 seconds. And also guys, in the log, I want to add something. I already copied it from your Spring, properties file from the documentations. I'm going to give you all these things. Go to my properties file because I want some more log, because you are not seeing how the channel is getting created, when the channel is getting closed, how Spring is handling the request. You might have some question. Okay, Vilas, do we have dispatcher servlet over here? Because in Spring MVC, I know whenever the request came first, the dispatcher servlet handles that, right? Do we have a dispatcher servlet concept? Are we having handler mapping, which will map the incoming request, going to help the dispatcher servlet to map the incoming request to one of the handler method, like how the dispatcher servlet will know, like to which controller to route the request. Let's say I'm sending this request called /consume, how the dispatcher servlet, let's say the dispatcher servlet will be the front controller, which is going to handle this request, right? How does the dispatcher servlet know that to whom this consume is going to be dispatched, to which controller? So we might have some concept like handler mapping, just like we have in Spring MVC. Do we have something similar? So if you are asking all this thing and trying to relate, then I'm going to tell you in a minute. Are you guys having this question right now in your mind? How this Netty server is working? Do we have a front controller concept? Are we having dispatcher sublet? Are we having request mapping? How the requests are getting mapped? And in which controller the request is getting routed? Are you getting questions like this? If you have ever done configuration in Spring Web MVC by yourself, okay, have you ever tried to dig into how Spring actually works, then you should be having this question. Okay, but if you have taken the shortcut route, directly jumped into Spring Boot, have never configured dispatcher servlet in your life, never studied about front controller, you will not have this question. And I'm telling this thing not to you guys who are in the call right now. I'm telling this thing to a broader audience who have never experienced what is dispatcher servlet and all that. But are you guys having this question in your mind? Are you having this question? Whether we have the dispatcher servlet concept and all that in Netty server as well, and how Netty is handling the request? Already popping up?
Yes. Yes. Yes, Abhilash.
Yes, this is the first thing you should think. Okay, you should ask me this question first. That do we have a dispatcher servlet concept? Because that's the front main, that's the front controller, which is actually going to handle the request and going to process that. So how that thing is happening, how Netty is handling that thing. So that is the exact thing that we're going to see over here. First of all, let me paste all the logs. Okay, I'll give you all these logs. So don't worry. Here I'm just activating my debug for the wave, Spring framework for wave. I just want to get some more log in the console so that I can show you everything. Reactor Netty, this is the Netty server. For that also I want to activate the debug. Access log I don't need. Channel, and I want to see when the channel is getting created, when the channel is getting closed and all that. Channel related log I also want, so I have activated this log as well. These three things will be enough. Let's just restart, stop and return. Okay, am I doing it in debug? Yes. So now you're gonna see a lot of things. So far a Netty server has been started, right? And our application started and whatever. Let me clear this log. Now let me go to this consume. Okay. Now I'm gonna just hit enter, and obviously whenever I'm gonna do enter, you know, like it is going to take how many seconds? 10 second delay we have given. How many second delay that we have given over here? 10 second delay over here, right? So it is going to take 10 seconds to give me the response. So that's fine. But I'm gonna hit it right now, and let's just see how everything is working. Let's say it is going to take 10 seconds of time. You can see right now, and after 10 seconds only it is going to give you the response back. See, now the response is gone. Now we are just printing something over here, number of course. So that's the line over here, and after that after 10 seconds this thing will be given back, and a lot of logs has been printed right now. Now let's analyze the log a little bit, and let's just see whether you are able to understand or not. First of all, in the threads and variables section, if you're going to go to the threads, you only have 3 threads right now, but this will gradually increase. As I said, whenever we're going to keep doing some more blocking operation, I'm going to be coming into that. But let's just go to the console and let's just try to understand the log and see what is happening. First of all, whatever things we understood, you can see there is a log from HTTP server operation. You don't have to worry about these names, right? Just look at this. New HTTP connection requesting read. I just hit one time this consume endpoint, right? But I got 2 things printed, new HTTP connection for a couple of times. And this may be happening because, sometime your browser send multiple requests for some different reason. That's a different concept, okay? Maybe you can just directly using a crawl command and use your, terminal to hit a endpoint also. That's fine. But right now I have been hit from the browser, maybe 2 times it is showing me new HTTP connection. But that's fine. Just ignore that. Just take one. New HTTP connection requesting read, okay? That means we have hit this endpoint, a new connection came to the server, and this is our connection ID. Or you can think this is your channel ID. And see, one of your reactor HTTP Neo thread is basically handling this thing. So if you're going to go to the thread and variable section, in this case, this is the reactor Neo 2 This is your worker thread from your event loop. This is the event loop, and this is your number of worker threads or event loop group. From that, one event loop is actually receiving the new connection, and which is requesting for read, and this is your channel ID or your connection ID, and basically this is your local remote machine, and this is local machine IP, and this is your remote machine IP. Just ignore this thing and you just understand this thing, plain simple English. New HTTP connection requesting read. Okay, second thing, increasing the pending responses count 1. So our new request came, so our server is tracking, and there is some concept of connection alive things. I don't want to go into that, so don't worry about this line. Imagine this is just for we got a new request, so there is a pending response that the server need to give, and this is just increasing some count for that. Don't worry about this line. Now this is the line which is a very important line. See, HTTP server from this log, and this is the channel ID. Now you see, handler is being applied, okay, and now the Spring framework kicks in, and the handler which is being applied over here is Reactor HTTP Handler Adapter. Okay, you don't have to remember this name. I'm just understand this line. Handler is being applied. What does this means? Well, this means that, one second. Okay, so this means that your Spring framework is right now kicking in. See guys, this channel creation, the request receiving, this part is done by your Netty server. Now the Netty server is giving this request to your Spring framework. Now between the Netty and the Spring there is a bridge. Okay, now the connection is being transferred, that request is being transferred to your Spring framework. Okay, and now this is the handler adapter, which is basically kind of handling this thing, and you can think this is the entry point for your Spring application when Netty is transferring this request or giving that connection request to the Spring framework. And exactly in this point, your dispatcher servlet kicks in. And in Netty, guys, we don't say this dispatcher servlet, we call this dispatcher handler, which is exactly same as your Spring Web MVC. This is also a kind of web handler or a dispatcher handler, which is just like a front main or a front controller kind of concept. Now you can see HTTP web handler adapter. Now this is, you can think, this is your entry point. This is your this is the this is even on top of the dispatcher servlet. We have this guy. This is kind of the dispatcher servlet. You can see we got a get request called consume. Whenever we had this hit this endpoint, now the front controller is actually right now receives, your Spring framework receives this request, right? And after we got the request, imagine your dispatcher handler is there, which basically handles the request, which is /consume. Now what the dispatcher handler is going to do? The dispatcher handler is going to route this request to your controller. Right now in my application, I may have so many controllers. Consumer controller is one of them. But now the dispatcher servlet, how it is going to know that, okay, in which controller, in which handler method, which can actually serve this request. For that, we need to go for request mapping. You already know about that. Here also, same concept. We have something called request mapping handler mapping. This request mapping handler mapping, this guy job is, it is going to route the requests. You can see consumer controller. Inside that, we have a method called consumer data, which can actually serve this request called /consume. Okay, the request mapping actually does that work. Okay, and the request mapping job is just to find where to send that request. Now it found the controller. To this controller, we need to send the request. To this method, we have to send the request. Now the request mapping, handler mapping, this guy just find the thing. It doesn't invoke the thing. So behind the scene, there is another component, what we call handler adapter, I think. Request mapping handler adapter. That guy is actually going to, invoke this particular method and execute this particular method. And after you execute that method, what is going to happen? Your server will give back the response, right? This is not blocking. So if it is Tomcat, it will wait. But here you are saying, I'm going to give you this data, but after 10 seconds of delay. So immediate response will be given to our client, and the client will say, okay, this is the data you're going to get, but after 10 seconds, you're going to get this data. So immediate the control will be returned, and it will say, okay, now the response is given, but after 10 seconds, I'm going to dispatch the data. So right now you can see that's why once it is returned, as it is it's not blocking, right? So the control will not stay, it will straight away return, right? So after that, you can see the dispatcher servlet uses this guy, ResponseBodyResultHandler. Okay, this is a result handler, and you can already learn from this name, response body. There is two things, right? Request body, whenever we receive a request, with that request, if there is something coming, that is something what we call request body. Now, whenever we are sending a response, with the response, if we are giving something in the body, that is what we call response body, right? Now the response body result handler. Now this guy helps the dispatcher servlet to send a response back. And this is right now how it is going to send the response. Now this request came from the browser. So the response it is going to give in the HTML format and the formatting and all that. This is what it just started preparing for the response. And after that, you can see the response, I think, is received over here. Here is my data. So there is some HTTP logging. Whenever the response is ready, it is going to write this thing. Here is my data. Writing, here is my data. Writing means it is writing this thing to the response. Okay. And after that, you can see last HTTP response frame. Then you can see completed 200 OK, right? Now the HTTP web handler adapter is basically the same guy. We actually, I told you, this request mapping, whenever we are going to send the request to this particular method to handle that request, it is going to execute that. Internally, there is something called HandlerAdapter, which basically helps this handler mapping to execute this method. Once this method will be executed, then only this data will be given, right? So the same guy you can see, it is saying web handler adapter, it is saying completed 200 OK. So that means 200 OK means now this is served and the data has been returned successfully to the response, and 200 OK is the status code. And after that, you can see decreasing pending request count to 0. Previously, increasing pending response count to 1, and now the decreasing the pending response count to 0, right? Because the response has already been served. Now the last HTTP packet was sent, terminating the channel. I told you once we already have opened the channel or the TCP connection, right? Within that only our request and response is basically getting processed. And now whenever we're sending the response, it is just going in packets. If you have studied electrical or communication engineering, you might have know how the data is being transferred inside a channel, right? It just goes in packets, as I have said. So the last HTTP packet was sent, and now the terminating the channel. Now the channel is not required, so it is just terminating the channel because the client and server communication is done. Okay, now the channel inbound receiver cancel. Inbound, there is a Netty internal of the channel. That is, the channel has a life cycle. The channel get registered, then created, registered, activated, then inactivated, then all that thing. Let's not go into that. But this is actually what is happening behind the scene, and all this thing you can see right now. I think someone of you was asking me this thing. See. Initially, reactor-http-nio-2, which is one of your event loop, handles the request, right? And then all these things processed by that event loop only. But you can see once we hit this request, so here only, as I said, the request mapping, handler mapping, this guy will find to whom I will route the request, who can actually serve the request. So it found the consumer controller. Inside that we have this consume data method which can actually handle the request, and using the handler adapter behind the scene, we're going to execute this method. Once we execute this, that this is going to take some time, and this is some kind of a blocking operation. So for that, this need to be uploaded, and once it uploaded, you can see we switch to some other thread like parallel one. This is one of the thread from the thread pool. This is not your event loop thread, right? This is one of the thread, as I said, from the thread pool right over here. We pick one thread and using that thread we make the call. This is not your event loop thread using what you are making the call. This is a completely different thread, right? So using that only you are making the call. You can see
Yeah, because that 10-second delay is there, right? So that will be that like writing here is my data will be displayed after 10 seconds.
Yes.
And before that, if the after that, if there is a rest call, that will be executed. That gets executed before printing here is my data, right?
Let's just do one thing. Okay. Let's just give 20-second delay. Okay. We're gonna see this one more time. 20-second delay. And
after that, can you write something like
1 second? I'm gonna actually make the rest call. Don't worry. So this is just for sample. I'm gonna say executing consume data method. Okay. Control S, restart, and let's just check the log. It will start my server and all. Okay, Netty has been started. I'm gonna clear this. Let's just send the request. Consume, enter. First the request came. Okay, you can see executing consume data, but the data has not still been written. You can see, so you can see this is basically the thread which is basically handling that request, right? And after that 20-second, you can see right now this parallel one is the thread, like the blocking thing, that delay thing was being invoked by this guy. And then, we switch back to the event loop again, it given back to the event loop again. And that is only, processing the same request. Okay. This is your executor thread pool that I told you, which is actually helping you to, that offloaded task is getting performed by this thing. This thing you will not see if you're gonna make the rest call. That's why I've shown you this thing, because otherwise you guys will be confused. So that's why only I've given this delay thing. But right now you can quickly make this rest call, and maybe I'm gonna tell you one last thing and then we can exit. Okay. So let's just make the rest call over here right now. That artificial delay I just removed. Okay. So I'm gonna just do web client. The web client is for the non-blocking call, and let's just create the web client. Okay, this is just like your REST template, and I'm gonna just create the web client right now in order to make a REST call to my producer application. So web client dot build builder dot build I can just do, and here I can just keep the base URL, and my base URL is I want to make a call to this endpoint, which will cause an artificial delay of 10 seconds. If you remember, if I'm going to hit this, it is not going to instantly give you the result, right? So I'm going to copy this, and this is going to be my base URL. I'll remove this guy, and this is my web client. Now using my web client, let's just make a REST call. So web client and dot get call I want to make. I want to make a get call to / whatever hello. Okay, this is my producer, right? So hello, and I'm gonna retrieve the data, and I'm gonna get only one single text, hello world. I think what I'm getting over here, hello world, right? This is a single text, right? So this is why I'm saying it mono. So I'm gonna say body to mono, and I'm gonna get the data. Okay, so I'm gonna get back my result. Okay, and this is my response, and now I can send my response directly instead of hard coding this. Now thing is, this is going to be a blocking call. This is going to make my application wait for 10 seconds or whatever. In the producer controller, 10-second delay. I'm gonna give 20-second delay, let's say, or 20-second delay. Okay, this is now this producer application is going to create a 20-second delay. So if I'm gonna go to my consumer application, so once my application reaches over here, let's say the event loop executes this, now it's gonna say, oh, okay, so this is a blocking call, this is gonna take some time, so this is gonna do what? This is gonna offload this, right? But here I think Why I have given the artificial delay previously, because I want to show you that thread pool which is getting used behind the scene. If you're gonna use like this, you may not get track of that thread pool, right? Because there will be some internal call will be made. So, but you can think like here, this will be a non-blocking call. After this, the response will be directly given, and the client will say, okay, the response is given, but whenever the response is ready and will come back, actually, I'm going to give you the actual response after that 10-second of delay or 20-second of delay, right? But the code immediately returns over here. The thread is actually not get blocked right over here, okay? So now if I'm going to relaunch this application, let's just analyze the log one more time. And in the same time, what I'm going to do, guys, like if you're going to hit this endpoint, you're going to get whatever this hello will give, you're going to get that as a response, right? So if I'm going to go over here, nothing fancy. If I'm going to go to my consume endpoint, if I'm going to hit it, there will be a 20-second delay. And after 20 seconds, you're going to get whatever it returns. Hello world, you're going to get hello world right over here after 20 seconds. Okay. Now the question is, whenever this is blocked, if someone else is going to hit the request, can the same event loop can handle the request? The answer is absolutely yes. And you can see is hello world right now. Okay, you can see right now, if we're gonna see our console threads and variable threads, you can see right now you have all, now we have a blocking operation, right? So all your event loop, like they are activated. And how many we have? We have 14, because I have 14 cores, so we got 14 event loop. So now let's just do one thing. I'm gonna show you the beauty of the event loop. Let's just have one more endpoint, simple endpoint. And I'm going to have another get mapping over here, right over here. And I'm going to say, let's say simple call, because here we're not doing any kind of blocking operation. So let's just restart our application. I'm going to show you something. Okay, before we start our application, what I'm going to do, I want to restrict the number of event loop that we have. And for that, I can just do a little bit of edit. Okay. And over here, in the VM arguments, I'm gonna configure something so that I can restrict the number of event loop my application will create. By default, it is creating 14. So I can use this, ioWorkerCount parameter started with -d. It has to be start with -d because it's a VM argument. And this is a property that I want to set. ioWorkerCount. How many worker thread I want to create? I want to create only one worker thread in any point of time. Okay. Now if you're going to do debug here. Okay. So in my application right now, if you're going to go to the threads and variable and threads, you'll have only one worker thread. See, this is the only worker thread we have. And in future also, this will not grow, I think. So let's just go ahead and hit our endpoint. So consume will delay it for 20 seconds. And there is one more we have created that's simple, I think. Okay, this is giving simple data. Let's just see, do we have this thing growing? No, this is still one event loop we have. So if I'm going to hit this endpoint, okay, by whom it will be picked up? It will be picked up by the same HTTP reactor nio-1. You can see we have already received the request to hello endpoints, and it is behind, the consume endpoint, and behind the scene it is making a call to the hello endpoint, right? And we haven't got the response yet. But in the meantime, if I'm going to hit if I'm going to hit simple, see, it is still working. See, if I'm going to hit this, by whom it is getting handled. See, reactor HTTP nio-1. And in the same time, I'm going to hit this. Who will handle this? Same thread. And see, it is not getting stuck. I'm going to get the result. See, I'm getting if it is Tomcat, it will stuck, because one thread cannot handle 2 requests at a time. But here you see, now I'm getting the result. Now the response has been given over here. Now I'm getting hello world, right? So if you're going to check all my logs, right, you can see all has been handled by the nio-1 only. It's all nio-1, right? HTTP nio-1, HTTP nio-1. That means it's the same worker thread that we have, the only one. This can actually help you to handle many web requests at a time. Okay, one event loop can process hundreds of requests. You can use Apache benchmark, send 20, 30, 50, 60 to 200 requests at a time, see whether it will be able to handle it or not. And absolutely it is going to able to handle that. Are you able to understand my point, whatever I'm saying? guys?
Yes, Abhilash.
We need to debug and see.
Yes. Now let's just debug it one more time, okay, for clarity. And guys, one more thing. You might have a question. Abhilash, you told me about two types of thread: boss thread, worker thread. Whenever you are starting your application, this thread is a boss or worker. This is a worker thread, okay? You are not actually able to see the boss thread here. If you want to see the boss thread, that's why I copied the properties. Whenever you are setting your BM arguments, right? This is for worker thread. There is one more for boss thread. This is IO selector count, okay? Now, if you're gonna do this, -d Reactor Netty IO select count and set it 1, okay? Generally the boss thread will be 1 or 2, and the boss thread is basically responsible to handle the connection, the incoming request. First you need to create the connection. The boss thread is actually going to be responsible for that, and generally the worker threads will be more, like you're gonna see 10, 20, 15 or something, right? So if you're gonna start this right now, we'll have one boss thread, one worker thread. If you're gonna set it explicitly, I think you'll be able to see it over here. You can see this is your boss thread, reactor HTTP select neo, and this is your worker thread. Where is your worker thread right now? Okay, let me hit the endpoint. Maybe after that I'm gonna get enter. Now see, neo to cam, right? This is your worker thread. This is going to handle the request all the time, and the select one is your boss thread. So if you're gonna go to the console, you can see you'll never see that select one over here. This is the worker thread all the time. This will be only be used. Okay. Now you can see all this log. One more time, just for your understanding, quickly to wrap up. The first important log is here. Okay. New HTTP connection. Okay. So your channel is getting created right over here. This is your connection ID or channel ID. Next important thing, this handler is being applied, and reactor HTTP handler adapter. This is the Netty and Spring bridge. Okay. Now the HTTP server, this is actually the Spring thing, and Spring is kicking in right over here. And this is just like your dispatcher servlet, right? Even the root of dispatcher servlet, you can think like this. You can already think, web handler adapter. Okay. If you're going to see there is a component called dispatcher handler. Okay. See, it implements web handler, right? Now, if you're going to see the component that you are getting over here, this I'm telling this as a dispatcher servlet, right? Or this dispatcher handler. Here is the entry point. It is handling your request right over here. Now, if you're going to go inside this adapter, see, it extends web handler decorator. Now this implements the same web handler only, right? That's why I'm telling you this is just like your dispatcher servlet. You are not getting any dispatcher handler log over here, but this is the one which is like, first getting your request and routing your request to handler mapping or the request mapping. And this is basically sending that request to this controller, this method. And after that, it is getting invoked by HandlerAdapter internally. And after that, the response body result handler is coming into the picture because the response has been sent, because this is a reactive application. So after the response is actually arrives, you can see the response is arriving over here. We are writing it using the logging. And after that, that has been returned to the response, and your last packet is sent, and we are terminating the channel. The open channel is being terminated, right? And all this thing we are doing using this one event loop. You want to know more about this? Everything that I have told you, Spring WebFlux doc, everything that I have told you, you can get over here. Okay. And if you can go to this component dispatcher handler, whatever I told you, I found it from here only. And here you can think like handler mapping. This component I told you, this is the component that we got over here, right over here, handler mapping, right? Mapped to this thing. So handler mapping job is what? Map a request to a handler. And after that, you got handler adapter. This is actually going to invoke that controller method, as I said. Help the dispatcher servlet to invoke the handler map to a request. Okay, so this is the thing. After the handler mapping, internally the handler adapter is invoking this method, and then only the response is being returned, and then only this guy is coming into the picture. Okay, and all that. So go ahead, right now you're free to do more research. Maybe this is pretty much it, and I think we can keep talking, but I think this is pretty much.
Abhilash, I have one doubt.
Yeah, Bamsi.
If you have multiple event loops and multiple requests, when your response comes back after some time, and does the same event loop handle it, or another event?
Yes, it's the same. It's the same event loop which will handle that, because I was explaining the same thing to somebody, right? Here, see, if this guy gonna send a request, okay, then for him the channel will be opened, right? Now this is the channel which will be registered with the event loop. So all the request and response will be done by this event loop only, right? So if this machine is sending a request, this event loop need to handle that. How come this event loop will know about this machine, isn't it? So the channel are registered over here, and whenever we are sending any request, it will be go to the event loop task queue, and every event loop will have their own event loop task queue, Bamsi. Okay, so whenever the event loop will offload, whenever that thing will be ready, it will be pushed back to the same event loop task queue, so the respective event loop can pick it up, can find the channel, and can send back the response. Okay, any other question? Right, nice question. Any other question?
Flash, I have one doubt.
Yeah, Harsha.
Yeah, so you kept only one event loop, right? So what happens if the event loop task is full, multiple requests?
So that is another thing, like what is the task queue size and all that. The same question Mahesh asked, but this is just to demo you, to show you that one event loop can handle so many requests. Okay, but that does that task queue automatically grows? That you can find out. You can do some homework on that. But don't treat that one thread less powerful. You know, programming language like Node.js have only one event loop. They all work in that event loop concept only. In JavaScript, you have the event loop concept. And in Node.js framework, let's say, there you have only one event loop. And with that event loop only, you'll be serving all the requests. Think in Spring Boot right now, we have 10, 14. So how much powerful we are. So don't underestimate even that power of one single event loop. Okay, good question. Yeah. I'll see you guys next time when, I don't know. I'll just let you guys know. All right. And maybe I have plans for Spring AI and all that. I'll tell you about the new courses, new launch and all that. Yeah, pretty soon. Okay. Thank you very much for joining, and I'll see you guys soon. And till then, bye-bye and happy coding.